Hey folks, Sega Sonic fan here, continuing this PC Engine GT repair. This is a PC Engine GT, really awesome handheld. This is a pain of a repair. This has been a total pain in the butt, but I believe I got it figured out finally. And I'm going to share that with you, so hopefully I will save you some pain, some heartache. Ugh. So, here's your controller board. The symptom with this one, after I recapped it, was one of the buttons didn't work. And it was this button right here, I guess button 1, right there. Or right there, in the controller. So I ended up having to pull up the schematics for the TG16 for this. And see if you can see this on my phone. Try to turn off the light here. Maybe that'll help. Nope, that didn't help. Little bit of a rundown, a little bit of an explanation. Gosh, this is such an annoying repair. So there's this board, right? And this has a ribbon cable that goes to the main board. So what's going on here? What's this chip? Well, this chip is labeled BU5782K. I could find no information on it, and that's because I'm pretty sure this is a custom chip that NEC made just for this unit. The reason why I'm pretty sure this is a custom chip is when you look at what's down here, you have a headphone port, which actually goes to this chip, and then you have the digital interface cables as well as there's two pins that go to the speaker output, and that's just from the speaker amp on the board. But this is obviously going to be multiplexing some of the signals. And what's going on here, this is the multiplexer that's inside it's a combination circuit. So there's a multiplexer in here, which is the same multiplexer that's inside a regular PC Engine controller. There's the secondary counter circuit that's inside the autofire controller to give you autofire. And then on top of that, it looks like there's also some op-amp circuitry to drive the headphone ports. There's some detect and op-amp circuitry inside of there. So it's doing a few things, and if I had to, I could actually build one of those completely outright, which would be kind of a fun, though incredibly time-consuming project. But if we looked on the other side here, we notice that there's no traces at all. So there's some interesting things that NEC did here. They didn't want to pay for a two-sided board, so in order to save costs, what they did is they patched connections. I don't know if patched is the right word, but they machined connections here using this conductive material. It's the same conductive material that the controller buttons use. It's pretty ingenious, I gotta say. +1 for NEC. That's a great way to save cost. And they're already using this material for the buttons and everything. So that's pretty cool. Downside to patching it this way is that there's quite a lot of resistance across these, and so the longer the trace is, the higher the resistance. And let me tell you, it's really high. So like this trace right here is actually 600 ohms. That one going across. This one, the questionable one, is 900 ohms. This one is about 130. This one's like 200 something. So the resistance varies greatly by length. So it's very interesting. None of those should really matter because these are digital inputs anyway. But I do believe part of the issue is this connection being really long, being 900 ohms. And so I think there's two fail states here. One is that being 900 ohms. But then you also have, this goes to some switch contacts. So these pads here, the black pads you see are the two pins right there, go back and forth on those pads. So you're going to have resistance because that's not going to be making perfect contact, especially after many years. So you have two places of increased resistance that are going to make your button press difficult. On top of that, I found out there was a short across two of the pins. And it could be a chicken or egg thing. I don't know which one caused which. Well, I mean, the short definitely caused something bad. Maybe it increased the resistance of that line or something weird. But the short was pretty bad. It was from the person who did the previous cap repair job, and they did it really fast and really messy and really cheap. And that's what happens. You get stuff breaking. So if you look over here in the schematic, how I found out the short was, if you zoom in here, you'll see that there are some inputs here. There's VDD, which is digital power supply, which is going to be 5 volts. There's D10, D1, DI0, DI1, DI2, DI3, select, and clock. So those are your inputs for the controller. That comes straight from the controller port on a TurboGrafx, which is essentially the outputs here. These are your outputs that are going to go to the same chip. What's cool is that this handheld version, the GT, uses the exact same chipset of the original PC Engine. It's these 6280, 6270, and 6240, I think. Anyway, there's these three main NEC chips. So if you follow those, if you look at those lines, we're having an error of just one button, right? So it's not going to be our select or our clock signals, because those multiplex all the buttons. So we would have at least two buttons not working, probably more if those weren't working. We also get button presses, so we know that the power supply rail is good, and we know that more than likely one of the digital inputs is going to be bad. So if we follow these traces here, they go to pins 22, 24, 25, and 26, K0 through K3. Those are your button inputs. And sure enough, between 22 and 24, I think it was, there was a little piece of solder caught between the pins. So I removed that, but the button still didn't work. And what eventually made the button work was when I patched this wire here. This is a nice test point for the button. So this goes to the IC direct. And then this is a ground signal. The ground signal changes depending on the state of your auto fire, because that's how you change the frequency of the button. Essentially, it'll pulse one of the ground rails. And so by patching this, by bypassing this trace, I'm pretty certain it's going to work, because that'll fix half the resistance, more than half the resistance issue that it's been having. If that doesn't work, though, what did work 100% of the time was patching this, connecting it completely to ground, which means that you won't get auto fire. It'll work, but you won't get auto fire. And so I got that working already. I'm trying to make sure that the auto fire is going to work too. And I'm pretty sure by patching this wire here and cleaning this guy again, the actual select switch is going to make sure that that's possible. So moral of the story is, don't pay for cheap cap repairs. When you do cap repairs, go slow. Don't splatter solder, and I don't know. Don't work on expensive systems if you don't know how to do cap repairs properly. And also clean your contacts. Also examine really unique stuff like this, which is cool, but it seems to have caused a problem. And lastly, try to avoid using mechanical switches whenever possible, because they always create problems down the road. This would have been way better if they used a momentary push button interface. But to do that, this chip would have had to incorporate a latching circuit as well as debounce circuitry, and that might have been too expensive in 2004 or whenever this was made. So that's it for this PC Engine GT repair video. Hope you learned something from this and have fun hacking. This is Sega Sonic Fan signing out.